Welcome back to another math video here at Math Rocks with Mr. Cox. This video is going to be all about graphing systems. That's right, I said graphing. So we're not going to be using algebra to actually solve where the intersections are between a line and a nonlinear equation, but we're going to be using graphing only. So stick around and you'll see how it works. Let's get it on! Let's go ahead and dive right into this here. So as I said already, we're going to be solving these graphically. So you're going to need some graph paper here. I've got my graph paper all ready to go here. And you can see in our system here, we have one that's a square root curve and the other's a line. Let's go ahead right now and let's graph the square root curve. So I'm going to use red for that. I'm going to go ahead and make a t-table down here. And I think the first thing you ought to be doing with square roots is finding the locator point or the beginning of the square root. And how we do that is we look at what makes this square root equal to 0. So x would need to be -2. And when that happens, -2 plus 2 is 0. The square root of 0 is 0 plus 3 is 3. So -2 comma 3 is going to be the beginning of that square root curve. All right, I'm going to use -1 next. If I do that, I'm going to get -1 plus 2 is 1. Square root of 1 is 1. 1 plus 3 is 4. So we got ourselves another point right over here. I'm going to go ahead this time and I'm actually going to use the value of 2. You'll see why right now. 2 plus 2 is 4 and the square root of 4 is 2, which is a nice even whole number to work with, and 2 plus 3 is 5. So now I'm going to go out to 2 comma 5, which is right here. And then I'm going to go ahead and I'm going to use the value of 7. 7 plus 2 would be 9. The square root of 9 is 3 plus 3 is 6. So 7, 1, 2, 3, 4, 5, 6, 7, and then 6 would be right here. Wait, I think I missed out. There we go. It's right there. And I'm going to go ahead and connect them. So there is my square root curve. Very good. All right, next up, let's go ahead and do the line. You can do it many ways here. This time I'm going to use a table. So I am going to use 0 as my x coordinate, and if I plug in a 0, I get a 1. 0 comma 1 is right here. If I plug in a 2, 2 plus 2 would be, 2 times 2 is 4, plus 1 is 5. So 2 comma 5, what? There it is. There we see right here where it's going to cross. And then we could do another point. I know if I plugged in a 1, I would get a 3, so that would be this point right here. And then go ahead and grab a ruler, and obviously I don't have one, so I'm just going to go ahead and keep following the pattern here so it's a little bit straighter. I'm going to go ahead and connect these as best I can. And when you do that, you will see where they intersect right there. And that point would be 2 comma 5. So the solution here to this system is 2 comma 5. So really what this is all about is graphing a line and some sort of a curve and then seeing where they intersect, and that's your answer. So there won't be any algebra involved here at all. It's just graphing. All right, so here's another one. This one is going to be an absolute value curve and a line once again. Let's go ahead and absolute value I'm going to do in green. My locator point would be, what would make this equal to 0 would be a 0. So my locator point is going to be 0 comma -4, and that's going to be, when I graph this, it's going to form some sort of a V curve, and that V vertex is going to be at 0, -4. So here it is, 1, 2, 3, 4. That's my 0, -4. And I'm going to go ahead and I'm going to make a table. So 0, -4 is here. I know there's going to be symmetry, so whatever I get for 1, it's going to be the same for -1 because they're both 1 away from 0. So if I plug in a 1, absolute value of 1 is 1. 1 minus 4 is -3. And this will be the exact same y value here. So that's going to be these 2 points here. If I plug in a 2, the absolute value of 2 is 2, and 2 minus 4 is -2. And therefore -2, -2 will also be there because of that symmetry. And you can see here, we can just continue out, keep going, going. And I am going to do my best here on my curve. So there it is. I'm going to go the other direction now. Oops, messed up a little bit there. Let's see if I can get that going there. There we go. Pretty close there. Not too bad. Remember, this is just a graph here. It's not the most amazing graph you've ever seen, but it definitely works. Let's go ahead and graph this. This time let's use the slope and the y-intercept. So the y-intercept is -1, and my slope is 1 over 2. So that means I'm going to go up 1, right 2, up 1, right 2, up 1, right 2. Oh wow, I see where it intersects over here. I can also work backwards, so it's going to go this direction here too. So now if I connect, I should get something about like this. Once again, if you're doing this at home on graph paper, please use a ruler. And you can see where they intersect. One of them would be at -2, -2. So that would be one solution to this. And the other solution would be the other coordinate. And that would be 1, 2, 3, 4, 5, 6, comma 2. So that would be our second solution here, 6, comma 2. As always, if you like what you see, please like, comment, or subscribe. Thank you, and now back to part 2. All right, the third and final example I want to show you about how to solve a system graphically involves a parabola, and it involves a line. So let's go ahead and on this one, let's find the vertex first. So what makes the parentheses equal to 0 for x would need to be 2. So our vertex is going to be at 2 comma, and then whatever is outside here is going to be our y coordinate here. So we have 2 comma -4. So 2 comma -4 is right here. I'm going to go ahead and make a t-table over here. And we know it's a parabola, so there's going to be some symmetry going on here. So what I mean by that is if we have symmetry, if we go one higher for our x and one lower, we should get the exact same value for y, and we will. So let's plug in a 3. 3 minus 2 is 1. 1 squared is 1. 1 minus 4 is -3. And you will get the same value there for 1. So I'm going to plot those points right here. Here it is. Now I'm going to move on to 4 and 0. If I plug in a 4, 4 minus 2 is 2, 2 squared is 4, and 4 minus 4 is 0. So these points are going to be there. So I'm going to go ahead and plot those points right here and here. I'm going to do one more on the low end and on the high end. I'm just going to try to fill out my graph a little bit more here. So if I plug in a 5, 5 minus 2 would be 3. 3 squared is 9. 9 minus 4 is 5. So 5 comma 5 and -1 comma 5 will also be points. So here's 5, 1, 2, 3, 4, 5. So here's our 5 comma 5, and -1, 5 will be right here. So go ahead now, and on your graph paper, let's complete this parabola here. So I'm going to go ahead and make my parabola on this side. I'm going to continue over here. And there it is. So there's my parabola. Now let's go ahead and let's do the line. I'm going to do this in green here. So our y-intercept would be 0, 2. So 0, 2 would be right there. From here, our slope is down 3, right 1. So I'm going to go down 3, 1, 2, 3, right 1, down 3, 1, 2, 3. Oh my gosh, I just found an intersection right there. I can also work backwards. I can go left 1 and up 3, and there's my other intersection. So at this point here, grab your ruler. You can go ahead and connect as best you can. I'm having a little issue right there. That's okay. I know where they intersect. So where do they intersect? They intersect down here at the vertex, and that was at 2, -4. So one of our solutions is 2, -4. Our other solution is right here, and that would be -1, 5. So once again, this is all about solving graphically. So you will need graph paper, and it's just a matter of making the graphs accurately as best you can, and then seeing where they intersect each other, and those are your solutions. Thanks for joining me here at Math Rocks with Mr. Cox.